I'm here in a secure, undisclosed location with another interesting vintage technology treasure. A friend of mine has loaned this to me, and I wanted to share it with you. Some of you will recognize this immediately, but the rest of you probably have never seen one of these. This is a Quest sound pressure level meter, and this is a professional model. Comes with a calibration module, and which is pretty unusual. I have a Radio Shack version of this meter in a plastic case, but this is metal, all metal, and is used in a more professional environment. So let's take a look at this this meter. I just put four new batteries in, two 9-volt batteries in the meter, and we can check it to just confirm. Yeah, we're in pretty good shape. And 2 batteries in the calibrator. Yep, we're in the green, so that's good. And you heard the tone. It's a 110 dB, 1000 hertz tone, as you can see right there on the panel. So the way this works is, we'll try to do this one-handed, is the sound pressure level meter measures sound pressure levels in any environment, whether you're in a quiet library or at the end of a runway with jets taking off. And they're used in the music industry, they're used in factories, any kind of an environment where you need to confirm sound pressure levels for safety's sake. For example, OSHA requires certain tests be run in certain environments to make sure that you're not exceeding pressure levels over extended periods of time. Not only are you not being exposed to loud explosions, instantaneous noises, but extended loud noises over a period of minutes and hours can do irreparable damage to your hearing. So companies would buy these meters and to comply with OSHA requirements in some cases, and this is one such device. You can see the different sound pressure level ranges from 70 up to 110, and I won't go into all the science that's involved and what those numbers mean, but we're just going to experiment a little bit with calibrating the device using the calibrator, and then we'll do some noise level comparisons with the meter. Here in this quiet room, we'll do some comparisons, and then we'll go outside and do some other tests like that to give you a feel for it, in case you've never seen one of these before. There's a microphone in the top of the unit that is omnidirectional, picks up sound, and then it indicates the sound pressure levels on the meter. This meter has a battery gauge on it, and then it also has the operation switch. There's a weighting switch and a speed switch. So the speed switch just works on, let's see if I can illustrate right now. And we're going to just talk, and I've got the unit on speed on fast, so the needle swings without any kind of buffering, and you'll see my voice at 70 dB. It's not quite 70, it's almost up to 70. So when it gets to 0, that's the 70 mark. And then anything below 0 is 70 minus and whatever. And anything above is 70 plus. So if I whistle, you can see that was about 78 dB. And so that's the fast weighting. Then our fast speed, and the slow speed, notice the difference. I just switched it. Notice the difference in the speed of the needle. It doesn't bob all over the place and move. It's a little slower, as opposed to the fast, So that's the fast and slow. So it just slows down and buffers the meter just a little bit. And you get, it doesn't average or anything like that, but you can get a little bit better reading on speech in a quiet room is around 65 to 70 dB, as you can see right here. And that would be pretty consistent with what you would read on a chart somewhere. The other setting is the weighting setting, and almost all good sound pressure level meters have a weight setting. The A setting registers almost all the sounds that you would typically read or you would hear by the human ear. So if you want to test what your ears are actually hearing, what pressure levels your ears might be sensing, you would the ear has certain ability to hear certain levels, frequencies, and then other frequencies roll off at a different level. So this compensates for that, and that's the A setting. And then the C setting is just scientific. It's a flat level. It doesn't compensate for any issues with the human ear. It's just a flat, straight across the board. All frequencies are heard by the microphone at the same level. So you'll notice that I'm talking at a normal tone of voice here. Notice how the needle is really moving all the way across my voice, the frequencies of my voice. If I switch it back to A, notice that it's compensating for what the human ear can hear, so it's not nearly as flat response curve. So it's just a response curve setting. Most of the time, if you were doing a scientific test of pure sound pressure levels at all different kinds of frequencies, you would switch it to the C level and you would get a flat response curve. And then if you wanted to do a more rounded off bell curve, not really bell curve, but more of a curve sensitivity on the microphone, you would set it to the A setting. So that's the difference. And then the AC out here is the output of what the meter is actually reading. It'll send out an AC voltage to a calibration device like a strip chart, a chart recorder, and it will log that information onto the chart recorder if you want to do an extended recording of sound pressure levels in an environment like a factory or something like that. Then there is one other, let's turn it off, there's one other hole here, calibration hole, that we would use if we were going to calibrate the device. So let me take it off of the foam and set it out here on the table. And we're going to turn the calibrator on, and that's a 1000 hertz tone at 110 dB. And with these new batteries, this probably should be pretty accurate, pretty calibrated by now. But let's just check it. We'll put the microphone together with the and 110 dB should be right at 0, and notice it is exactly on 0. If we switch it to the 100 scale, 110, it should be right at 110, and it's just a little bit off, but not enough to worry about. It's just a little bit low. You see that now. So that's the advantage in having a calibrator, because you don't know, with age and battery life and all of that, you don't know how the device is going to perform if you don't have a calibration device. So it's a pretty cool find. I'm hoping that I can find someone who may be interested in purchasing this. Oops. But if not, it was very kind of my good friend Josh to make it available to me. I printed out a manual for the device, and it's just going to keep it there in the box. So there you have it. The Quest sound pressure level, SPL, sound pressure level meter. Let's see if we can find a date on this. You know, the newer stuff would be digital. There wouldn't be an analog meter. But you have to keep in mind that a lot of these meters, the value in having a needle is that you can actually see the needle move. So you can move the meter around the room, and the needle will rise and lower, raise and lower depending on the noise level. So visually, it's a much more useful tool to have an analog meter like this, a needle meter, as opposed to digits. And some of you that work on antique radios and electronics know what I'm talking about. When you're aligning a radio or a TV, you will typically use a meter with a needle because you want to adjust things and just glance over and look at the needle going up and down as you're tweaking components, transformers, potentiometers, and such. And you're not so much concerned about the actual number that's displayed on the meter, in this case a digital meter. You're looking at all these numbers bopping around. All you're really looking for is a high and a low of the needle swing, and that's the advantage of having a needle on an SPL meter, another value. Let's see if I can find a date in this manual. Okay, as near as I can tell, the unit was produced and sold in 1985, 86, 87, somewhere in that range. So 36, 40 years old, somewhere in that range, 36 years old. And obviously still works like it did the day it was produced. Okay, we're in a gymnasium. With kids yelling.